Hello everyone, I'm going to show you how to generalize linear features using point remove algorithm. So we are going to add the boundaries shapefile, for example, to this my data. So I shall go here, I shall add the boundaries shapefile, then I shall click add. Then you shall see on the layers panel the boundaries shapefile has been added. So I can turn off the word shapefile, and you can see that the boundaries are shown here. So the next step, since we the only line feature that we have are all polygons, so we are going to change, or I'm going to show you how to convert polygons to line features. So we shall go to Windows, then search, then on this table that here you shall type polygon to line features, polygon to line features, and click enter. So you can see this one is feature to line, feature to polygon. So polygon to line, double click there, then on this table you shall input the shapefile that you want to be converted to line feature. So for our case is boundaries, so I shall click boundaries, then when they are already here I shall click OK. So I shall save it as world lines, and I shall click OK. And correct this one by adding some information. World lines, so it's world, or okay, we are going to save it as world lines. I shall click OK. So and you shall close this one here. So you can see the polygon has been converted to line. So we are going to close these world boundaries and we are left with world lines. So I shall close there, then allow me to shorten these. So the next step is now to generalize these world lines using point remove algorithm. So the point remove algorithm, some coordinates will be removed, for example from these world lines shapefile. So we are going to click on Arc toolbox, then go to cartography tool, then generalization by double clicking, then I shall click simplify line. So double click there, then on this table input the lines that you want to be simplified. Right, for mine is world lines. I double click, then I shall save it as world lines, but point removed, point remove, since it is the algorithm that we shall use. So you can see here we are going to use the first algorithm as point remove for this video, and then we are going to use simplification tolerance. For example, if I type simplification tolerance as 0, you shall find that an error will occur. This says that the simplification tolerance must be greater than 0. So it must be greater than 0. So to make our tolerance, the simplification tolerance parameter value determines the degree of simplification. The larger the tolerance, the more coarse the resulting geometry. Smaller tolerances generate geometry that is more accurate or more accurately represent the input. So we are going to use the smallest value possible, for example 0.1. So but there you can use 0.001, but a value that is smallest, so but greater than 0. So I shall click OK, and you shall see some there is running that is going on. So you will see that this layer here has been added. So we are going to see that, so we can zoom in and out, and you can see that these two layers here are on, for example this one and this one here. So we are going to see which layer is which. So when I turn the world layers off, you shall see we shall remain with the world lines, but for the point remove, world lines for the point remove. So if I turn this layer for the world lines, which was there before, you can see how it appears. This is just that we have zoomed, so you can see the effect of point remove. So much of these points have been removed from the data that is supposed to be. So that's why we can conclude that point remove algorithm in generalization, some coordinate are removed. So for the next video, I'm going to show you how generalization takes place in bend simplify, weighted area, and effective area. So follow, like, comment, and subscribe. Thank you. We can save our work. Let me show you how to save this work. For example, this. So we need world lines for point remove. So I shall put off the world lines, and if I zoom in, you shall see it appears as it is. So I shall go to file, then I shall go go to files, then export data. On this table, you shall go to and name the folder that you need your data to be exported to. For example, my folder here, my folder here, then save as type of PDF, EMF. So for me, I'm going to save it as PDF. I shall click PDF. Then for the resolution, I prefer 300 so that it can be or my details can be seen. So I cannot put 150 because much of the details will be lost. So I shall click save. Then you can go now to, I can go to desktop. For example, I can go to desktop and find where my data has been saved. For example, when I click here, you will see that when I click here, you will see that this data will appear as we have saved it in form of PDF, in desktop. So thanks. Follow for the next linear features, generalization,